Hi there, Mr. Holcomb here with another episode of Math Behind the Module. Okay, Lesson 7, Relationship between Visual Fraction Models and Equations. Now, the first term that we're going to see here in this first example is what you are asked to model the following using a partitive interpretation. What that really means is interpret it in parts. So if I were to ask you what's 6 divided by 2 is, it means how many 2's are in 6. So 2 plus 2 plus 2 equals 6, so there are 3 2's in 6. So therefore, 6 divided by 2 equals 3. Okay, that's just a basic example of what we're going to be doing in this lesson. So if we model the following using a partitive interpretation, what we're really saying is how many 2/5 are in 3/4. Or in other words, 2/5 of what number is 3/4. 2/5 of what number is 3/4? Just like here, 2 of what number is 6? If we had 2 3's, it'd be 6. 3 of what number is 6? 2. Okay? So 2/5 of what number is 3/4? So in order to do a model now, the denominator of our divisor tells us how many squares we're going to do. So I want 5. 1, 2, 3, 4, 5. Okay. So here's our 5 squares. We want to shade 2 of those 5 squares. So there's 1. There's 2. So this here is my 3/4. So 2/5 of what number is 3/4? Is what this question's asking. So I want to know what this whole thing is, because this is 2/5 and that is equivalent to 3/4. Well, if I cut 3/4 into 2 pieces, that'd be 3/8 each. Because 3/8 plus 3/8 equals 6/8, which equals 3/4. Okay? So if every single square is worth 3/8, right? And put this up to here. Every single square is worth 3/8. And we know this is 3/4 or 6/8, and the question's asking, what's that whole thing? So it says shade 2 of the 5 sections, 2/5. Let the part that is known 3/4. Label the part that is known 3/4. 3/4 is that 2/5. Make notes below of the math sentences needed to solve the problem. Okay, so what did we do up here to find that 3/8? Okay, we took half of 3/4, which equals 3/8, and then we multiplied it by 5. Because we have 3/8, we have 5 squares that are all equal to 3/8, so that's the same as saying 3/8 times 5. And that's going to equal 15/8. Okay, so let's take a look at what we did here. If I bring this down, first thing we did, we look back at the model, which is right here. Scroll up a little bit. have this model here. And we were talking about 3/4 divided by 2/5. So the 5 down below told us how many squares we were going to use, which is 5. And then 2 of them is equivalent to the 3/4 over here. And then we divided that by 2 and got 3/8 each. And then if all were worth 3/8, we multiply by 5. So what we're really doing is dividing by 2 and then multiplying by the denominator 5. So we found half of 3/4. That's the same as dividing by 2. Then we took the result and multiplied it by 5. So we divided by the numerator here. Okay, we divided by 2, and then we multiplied by 5. The next step says we can record this process using multiplication. So 3/4 divided by 2/5 equals 1/2 times 3/4 times 5. So we had the fraction 2/5 right here. So we took the numerator and called it a half. And then the denominator and made that a 5. So we divided by the numerator and multiplied by the denominator. Okay? Then what we're actually doing is this step. And it says, how can you show that 1/2 times 3/4 times 5 is equal to 3/4 times 5/2? So they're saying 1/2, and then this 5 out here is equivalent to 5/2, right? So we have this 1/2 here, 1/2 times 5, and that equals 5/2, because we can consider that 5/2. Okay. So we take 3/4 divided by 2/5 and 3/4 times 5/2. Therefore, since we are multiplying, we can rearrange the order of our factors. 1/2 times 3/4 times 5 equals 3/4 times 1/2 times 5, and 1/2 times 5 is 5/2. So it gets us back to that 3/4 5/2. Okay. So since 3/4 divided by 2/5 is equal to 1/2 times 3/4 times 5, 1/2 times 5 is 5/2. So we're taking the division here, and we're flipping over the 2/5 and calling it 5/2 and multiplying. Okay? And finally we're leading up to something here. And that is to solve the division problem, we can invert the divisor and multiply. This is called invert and multiply method. I call it, and you've heard me say it in class, flip it and switch it. Okay, so in other words, we have a multiplication, a division problem, and we're going to flip this and multiply. So 3/4 divided by 2/5 is the same as 3/4 times 5/2. That was a really lengthy description as to where that comes from using this model. But it's just simply leading up to that flip it and switch it problem. So model the following using a measurement interpretation. So we're taking 3/5. We're really saying how many quarters are in 3/5, or 3/5 is how many quarters, or fourths. Okay, 3/4 is how many fourths, or 3/5 is how many fourths. Okay, so we're going to do a model. What we're dividing by is what our model is going to be comprised of. So we're dividing by 1/4. We're going to quarter this. Okay. But the problem with this is 3/5 divided by 1/4. If we go back to that last problem here, it's 3/4 divided by 5/2. we were able to divide those 3/4 into 2 pieces and find out what each one was worth. We had 2/5. 2 out of 5. In this case, we have 1 out of 4 is 3/5. 3/5 divided by 1/4. So 3/5 is how many fourths we're going to have to convert the whole and the divisor to the same fractional units first. Okay, so what we need to do is, let me move my model. Okay, I made it into pieces, so never mind. Okay. So 3/5 divided by 1/4 equals, we want the same denominator. 5, 10, 15, 20, 4, 8, 12, 16, 20. You finally get to a same common denominator at 20. So if I multiply 5 by 4 to get 23 times 4 is 12. So 3/5 equals 12 20s. Divided by, I want 20 down here again. 4 times 5 is 20. 1 times 5 is 5. So we're really taking 12 20s divided by 5 20s. Okay? So I don't want my model to be quarters. I need it to be these broken into fifths. So if I break those all into fifths, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up, and I have 20 squares. So now I already know that 3/5 is 12 20ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is right here. This is 12 20ths, or 3/5. And that's going to be all shaded. Okay, so we're shading all of these, and these are the unshaded portion. And now we want to know how many 5 20ths are in there. So we have 1, 2, 3, 4, 5. There's 1. So that's 5 20ths. 1, 2, 3, 4, 5 is 2. And then we have 1, 2 out of 5. 3, 4, 5 would bring us out to here, but they aren't all shaded. Only 2 of them are. Okay, so now if we take that rule, we're going to take 12 over 20. And instead of dividing, we're going to multiply. We're going to take that 5 over 20 and flip it. And then these 20s cancel, and I get 12 over 5. Well, 5 will go into 12 2 times, the remainder of 2. And that's where we get our 1, 2, and 2/5. And that's where we come up with this answer. Okay, example 3. 2/3 divided by 3/4. So we have a 3, we have a 4, so 4 times 3 is 12, common denominator. So it's 12, 12, and 3 times 4 is 12, so 4 times 2 is 8. So 2/3 is equivalent to 8/12. 4 goes into 12 3 times. 3 times 3 is 9. So 3/4 is equivalent to 9/12. So now we have 8/12 divided by 9/12. So I'm going to make a diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12s. So there's our diagram. We're going to shade 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's 8/12 or 2/3. And we're going to divide them into 3/4. Okay, so if we draw another diagram next to it, here's another way to do it. Of the same length, and in this one we have 12 marks as well. 12 boxes. We're going to do this one in thirds. So this would be 1/3, 2/3, 3/3. 1/3, 2/3, 3/3 would be here. 1/3, 2/3, 3/3 is here. 1/3, 2/3, 3/3 is there. So if we split that into thirds, 2/3, and this one into quarters, 3/4. Let me use blue here. We have 3 groups of 4. We have 4 groups of 3. And then when we shade this one, we're getting 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. We now have one more than the other one shaded. So 8/9 of a group of 3/4 is 2/3. Okay, that one's a little more confusing to understand. We have 8/9 in 2/3. 8/9 of a group of 3/4 is in 2/3. Not sure if I like that. The models sometimes make it more difficult. Now watch how easy it is to do without the model, using what they call, let's go back, invert and multiply method. I call it flip it and switch it. So if we go back to this problem here, flip it and switch it is simply leave the first fraction alone, switch to multiplication, and flip it. And 4 times 2 is 8. 3 times 3 is 8. So 1, 2, 3, 4, 5, 6, 7, 8 out of 9 is equivalent to this set of 3/4. So the answer is 8/4. Okay, so show the number sentence below. So let's make this a little clearer. Let's do a diagram. So if I split this into quarters, 1, 2, 3, 4. And I know that this portion is 2/3. Okay, we're taking that amount, 2/3, and we're dividing it by 3/4. And this whole thing is 8/9. Okay, show the number sentence below. You just simply say 2 divided by 2/3 divided by 3/4 equals 8/12 divided by 9/12, which equals, and then we also have this rule, if the denominators are the same, you just divide the numerator, 8 divided by 9. Or else this flips it and switches. Okay, that's the end of this lesson. Invert and multiply to divide. The models are just simply designed to give you a visual Oftentimes that makes it more confusing. Just remember to flip it and switch it. Okay, and it's all right here. AB stay the same. Divide turn to times, C over D turns to D over C. So 2/3 stays the same. Switch it to times, 4 over 1, 8 over 3. Okay, now go to your problem set.